Okay, so sorry for a bit of a delay. My internet decided to go down right before I started streaming, which is good timing, but I took the opportunity to move my wireless router a little closer to where my office is. So hopefully I'll have better internet. I also bumped my frame rate down to 30 frames a second, so we'll see if anyone actually notices. This isn't exactly high speed content, but hopefully that should also help when I'm compiling code. Maybe my frame rate won't drop so hard. So we'll see. We'll try it out. I think for next week, what I'm going to end up doing is I have a pretty powerful machine that I use as a build server. I'm probably going to move it into my office and start doing my stream from that machine instead of my laptop because it has a much more powerful CPU and at least some kind of discrete video card in it. So maybe it'll be a more reliable for streaming and won't be a problem. I just don't have it set up with a desktop environment at all right now, and I haven't had time to do that. So, yeah, hopefully next week we'll be back up to 60 frames per second and hopefully less stuttery when internet is a problem. So, uh, I don't have any real plugs today. If you're interested in Rust support, come to Rust. Check out rust-experts.com. If you're interested in embedded Rust, come check out Oxidize, although our tickets are sold out, so there's only workshop tickets left. Do sign up for the waitlist if you are interested, because we may open up more tickets later, and we're going to be going first come, first serve out of the waitlist. So do put your name on the waitlist if you're interested, because that's how you will get tickets. Since the last stream last week, I finally got fed up. In previous streams, I've used a library called SS Marshall, which is a no standard compatible Serday front end or back end. I don't. Yeah, basically you can use it with Serday so that it can do serialization of messages and it works in no standard. And we're using that for the packets that we've been sending over the radio. But I've complained on the stream and outside of the stream about how it doesn't support variable length messages. So if you wanted to send like some UTF-8 strings that sometimes are 5 characters and are sometimes are 100 characters. You can't really do that. Or even sending like binary data. Like if I wanted to send a binary packet over over some kind of structure using Serday, I wouldn't be able to do that. Or if I did that, the packets would always be a fixed length. So if the max packet size was like 1,000 characters or something, you'd send 1,000 characters even if the packet was only 30 bytes, which is not great. So I've gone out and used some inspirations of a couple existing Serday backends, primarily SS Marshall, which is what we were using before, bin code, which is pretty close to what I want anyway, but it doesn't officially support no standard. There are some forks of it, but they're not officially supported. And Jorge or Japarek wrote a library called SerdayJSON Core, which is almost exactly the same thing as SerdayJSON, except for that it uses heapless data structures. So he's written a library called Heapless, which is kind of no standard versions of things like string and vec and hash maps and stuff like that, except for they have a pre-known maximum size. So you don't have to do any heap allocations, but you do have to stack allocate or statically allocate a chunk of data that is the correct size. So for example, if you want a string that is as big as 128 bytes, you can have a dynamically sized string as long as it fits inside of 128 bytes, and it will allocate those 128 bytes, but it can do it on the stack or on a statically allocated chunk of memory, which is really nice in an embedded context. So I've decided to kind of squish all three of those together, and I've written a library that I call Postcard. And I can talk about my design goals a little bit, but essentially, kind of like SerdayJSON Core, it will use heapless data structures so that everything can be allocated on the stack. I also, other than that, it's pretty much exactly like SS Marshall or bin code, with the exception that for variable sized data like strings or U8 slices and things like that, instead of just using a usize, which on a 32-bit machine would be 4 bytes, or on a 64-bit machine would be 64 bytes, which would also cause a problem if you're sending data from one machine to another, which I am. Like my desktop 64-bit and my microcontroller is 32-bit, so that would already be a problem if I was just using U sizes because they would be differently sized on different machines. It uses something called a varant, which is a concept I learned about from Google's protobuf libraries, where you can have an integer that's actually a variable size, where if you only use the first 7 bits, so up to 127, you will send that in only 1 byte. And what it uses is it actually uses the most significant bit to say, is there more data? So what it does is if the top bit is set, then it's going to be keep looking for more bytes, and it's going to look at all the ones until it finds one with the top bit is clear, and then it's going to say, okay, this slice of bytes now needs to get turned into a number. And this is really nice because if you're only sending something like 32 characters, then your size is only 1 byte. But if you decide to send something bigger, like 250 characters, then your size is going to be 2 bytes. So it kind of scales based on what you're using. And I have a link here that explains, or it's the protobuf docs of how they explain varants, so I would check it out. But essentially I'm using that. I also use that for the enum variants. So again, if you have an enum that only has 5 variants or 10 variants in it, it will only use 1 byte instead of normally on Rust, it always uses a U32 or a 32-bit number to store which variant this is, which if you only have like 10 or 20 enum variants, then that actually ends up being kind of wasteful because it is going to use 4 bytes even though it'll only really ever use one of those bytes to tell what it is. So I do the same thing for variants. Yeah, I use heapless data structures everywhere like Serday JSON core. Eventually I want to add a standard feature that instead of using the heapless data structures, you can go straight to a string or a vec if you're on a desktop, because I expect this library to be used about half the time on an embedded system, like from your embedded system generating and reading these messages, and then the other half of the time on your PC or whatever, actually deserializing these messages or sending messages back to the embedded system. So yeah, I have a sort of working version of this. So I have it actually does work, at least I haven't tried it on my embedded system yet, but I've written tests and the tests pass. So I've got serialization and deserialization, and right now the code's really ugly because I've kind of copied and pasted from each of those sources like bin code and Serday JSON core and SS Marshall, and the Serday project provides like a template if you're writing one of these like serializers and deserializers, and so like all the comments are really wrong because they're for like the proof of concept JSON example that they use in that project. So don't look at the comments yet, but I have a bunch of tests already that prove that it does work, at least on a desktop. So what I'm going to do today to actually show you that, because I didn't do any of that development on stream, I'm going to clean up my tests, because right now I have a bunch of copy and paste tests, and I'm going to clean that up into one like clean test module where it does like a round trip of serialization and deserialization. So you give it like a message and the bytes that it's supposed to serialize to, and it will serialize it into that, check that it matches, deserialize it back from the bytes, and make sure that it deserializes cleanly from that, and that all works. So I have that in the tests, but they're kind of all over the place. Another thing, I probably won't get to it today. Originally I was going to make that varant type publicly exportable, so you could use that in your own project, like if you wanted to have those varants in there. The problem is Serday, at least as far as I know, doesn't really like the concept of fields that can be variably length that you can't really tell how variably sized they are. So like you don't prefix them with a size, or if it's like JSON, you put like square brackets around it so that it can parse where it is. I may end up re-exporting those again in the future if I can figure out how to do it, but I've got some deadlines because I plan to use some of these components in the workshops at Oxidize. Right now I have kind of like a much more hacky version of this, and I'd like to get the cleaner, nicer version used for my workshop at Oxidize. So today is going to be less about working with alarm clocks and more about building some stuff that's going to be useful for both the Internet of Stream projects and my Oxidize workshops, because they're actually going to be on the same hardware, and I'm probably going to use a lot of the Internet of Stream's code as a building block for the workshop participants because we're using the same hardware. So while I did get a bunch of hardware in the mail, so I have a bag of hardware here with cool things like 7-segment displays. I don't know if you can, here you go, like 7-segment displays that I'm going to use in the alarm clock. Also things like serial character LCDs, so from SparkFun, that are eventually going to be my alarm clock. I have all these fun parts, but I have real world deadlines, so I'm going to at least try and stream some of the stuff that I'm building for my real world deadlines, so that I'm not going like 2 or 3 weeks without doing a stream, even though I am very ridiculously busy. So we're going to work on that today, and hopefully that's going to be useful and kind of make up for the fact that I didn't do any of this stuff on stream. So, let's go ahead and get started. And as always, I'm not paying attention to the YouTube. Well, I'll go look at it right now to see if anyone's left any comments, but I don't generally watch my YouTube comments. If you want to talk to me, go ahead and join Rust Embedded at irc.mozilla.org. So that address is here. Go ahead and hop on IRC. And yeah, come talk to me. Otherwise, I generally go back and I look at the comments later, but not in live. So if you want to talk to me, come jump on IRC, and I'm happy to take questions and stuff. But I'm going to go ahead and get started. So right now I have tests. So what I'm going to do is I'm going to leave those all there. And from I'm just going to do a cargo watch. So every time my working directory changes, it's going to rerun this command. It's going to run cargo test. And the way that I have this working, even though it is a no standard crate, I configurably, so if we don't have the test config attribute set, so not test, then we export everything as no standard. Otherwise, haha, it's a standard crate, which allows me to do things like run tests in a no standard mode. So I use that, and it works for everything except for when I try and do things like print. Then it gets very upset that it can't compile, but usually that's only temporary, and usually I forget to put that back. So we're going to take all these tests, and like half of them, because I kind of built this iteratively, half of them are in serialize, and then I copied and pasted all of those same exact tests over into deserialize, and then added a deserialize step. So what I'm going to do is I'm going to make a new kind of like integration test module that does all of this deserialization and stuff. And there's still some stuff I don't support, like I haven't implemented maps, so things like if you were serializing and deserializing a hash map right now, it would just panic, which is bad. I do plan to add support for that right now, but I don't need it right now, so I haven't done it. I know how I would do it, but you know, in the interest of time, I have not. So we'll go through this. Let's go ahead and make I'll actually get another CD. Where is this? This is in Ferris Postcard maker. I'm gonna make a test director, I think is what it's Rust integration tests, because one module test directory. Okay, oops. Move tests, because a lot of times integration test. So I'm going to make a new touch tests loopback.rs. So hopefully this should, yep, okay, cool. So we can see in my test runner that it has picked up my loopback tests, which is wonderful. So I need to, let's go and make sure that I can get this to build. So use Postcard. Let's make sure this actually works. Yep, that works. So then I need use Saturday, serialize, deserialize. Yep. Use. I want to vec, which is my serialization method. So it serializes it to a heapless vec. And then I need a from bytes. And then I probably also want use heapless string vec. I'm gonna need these eventually, I'm almost certain. So let's just try and avoid some compile errors. And then for right now, I'm going to allow unused imports, because eventually I'll get rid of this, but this will make my editor happy while I'm doing things. So test, let's loop back. So now it should run one test with loopback. Excellent. So what I'm going to end up having is I'm actually going to have a function that is test1 that takes some kind of t, where it's going to take the data, which is a t. So this is a generic function, and then the serialized rep. So this is the serialized representation where it's going to take a U8 slice, because this is what it should be serialized as. And then I need to put some trait bounds on this, where t serialize, deserialize, because it's going to need to be something that's serializable and deserializable. Deserialize. What does that end up looking like? I need it to be. Where deserialize? Oh, I need to give it a lifetime. Okay, so that's to the lifetime of the slice buffer that I have. So this is, I just need a lifetime, because there's deserialize owned, which will deserialize it in a certain way, but let's do this. Actually, let's call it DE, because it's deserialized, and this might be the wrong lifetime, but this will make it compile for now, and if I'm wrong, it won't compile. Cool, so that works. So what do I need to do? So I need to, and let me also throw in a, well, no, I'll get the len. The other thing I was going to add is make sure the length is there, but I'm actually going to make sure that the length is going to match whatever the serialized representation is, so that's fine. Yeah. Does T have to be, it's deserializable. Whatever. We'll figure out lifetimes in a bit. Said, that's signing myself up for problems. But, okay, so the loose structure of my test is going to be something like, let serialized equals, it's going to be, and we're going to have a vec of U8, and then the way heapless works, so I know I'm also going to need heapless const star. So this uses some type trickery to get you variably sized arrays, because Rust doesn't officially support numeric generics. So like in C++, you can say like, I have a function that's generic over arrays of any size, kind of like how Rust generics work, but Rust doesn't have that yet. There's an open issue for it, but it doesn't exist yet. So this uses some magic type system trickery. So we're just going to use a 2048 because we are on a desktop and we can do that. So we're going to do two vec of reference to data dot unwrap, because we're going to test and it's okay to unwrap things. Yep, that still compiles. So I can do things like test one. What do I want? I want, I don't know, let's do true. I know this is going to serialize to 0, 1. this should work. This should be a really simple, like, serializes to a Boolean is serialized to true, and that's one. And then we should be able to do assert equal serialized dot len is the same as serialized representation dot len. And then we can assert eq serialized dot deref. So I know this isn't going to work because I don't have use core ops deref, because I like a heapless vec can be dereferenced to a U8 slice because then they're directly comparable. So this should work. Yep. And then I should be able to let deserialized, which should be also a vec. Well, no, it should be a t equals from bytes serialized dot deref. So I get it as a byte slice, and I give that into from bytes, and then this should be this. So let's from bytes. Serialized does not live long enough. Right. Because this actually should not be the same. This should be tick D, where serial rep is actually a different lifetime. Dropped here while still borrowed. Do I need to do this like in a... This might be... Doop, doop, doop. Look, now it gets dropped there. What are you talking about? Serialized lifetime? DE. Because this has to be deserializable. Well, let's just, for now, and then we should be able to assert eq. This is going to end up being like, oh, I thought this was going to be fast, and then I'm going to end up fighting lifetime errors for reasons that are uncomfortable. Because I have 2vec data, because that's serialized. TDE bound. So T needs to be plus DE. Jonas, apparently not, but I will keep working on this. And then assert equals that data and deserialize should be equal. And then I probably also need, T also needs to implement eq and partial eq. Partial eq and debug. Where are you? Core format debug. Serialized does not live long enough. Lifetime DE. So it needs to live the lifetime of DE. But so the problem is, from bytes is saying that essentially whatever deserialized is, Does T need to be DE? Is this a thing? This is not how trade bounds work. Let's see. DE defined here. A does live longer. Serialized dropped here while still in bounds. Serialized dropped here. Why is serialized dropped at... I was going to say serialized is dropped there. Let's see. And data. So and data is going to be fine because and data, because data lives the lifetime of this because we have ownership here because it is fine. Borrowed value. Okay, you know what? I think let's let by sly, which is a DE U8 equals this dot dref, and then by sly. Let's see if we can trick it into giving me more useful information. Borrowed value does not require that serialized is borrowed for DE. This is just going to be a video of me struggling with Rust lifetimes. So dref, but the deserialization only needs to, so my deserialized T only needs to live, like the thing is I just need deserialized to be dropped. Deserialized is dropped here because this is the scope of deserialized. I mean, I'm going to cheat for right now, and then what I'm going to do is I'm going to use I need, what do I need? I need a standard vac, not a heapless vac. Where does standard vac live? Standard vac, doesn't it? Let x equals yeah. And then what is rust vac? No. Rust vac. There's like a extend from slice. X dot extend. What are you? Serialize dot dref dot iter dot cloned. And then I'm going to use cert. Well, byte slice is fine, but this is also fine. X is dropped here while still borrowed. What do you need to live for? T, I guess it needs to probably live as long as T. What if I get rid of this bound? Is this too much? No, this is not too much. just... That's gonna work, but it's not really what I want. Let's see if it's smart enough, though. When I say smart enough, I mean, let's see if this... Nope, sure doesn't. Byte slice. Okay, well, if someone in chat knows what I'm doing wrong here, let me know. But this is a test, and I'm okay with kind of cheating. So that's fine. So let's actually full screen this and view layout. Yeah, let's do some rows. And let's go to deserialize, because deserialize actually has the interesting tests here. So let's just kind of go through my tests one by one, and I can kind of explain why my expected data is this. So I'm actually going to move this up onto a different window that you can't see, but I'll let you know if tests fail. But just so I can give you a full screen while also see if my tests pass. So let's add some test 1 false. That should be that. Test 1. Let's start even with the simple types. This is going to be the same thing as that. So tests are passing still. So let's do some U8s. So test 1. I probably could make a macro for all this, but I won't. So the number 5 U8, and this is going to serialize to 5, unsurprisingly. So that's this one, and then U16. So let's take my U16, and then I'm going to, so an interesting thing here is that I am serializing things in little endian. So you can see like the C7, you can see that this is the first byte in the slice, and I do this because my embedded systems are almost universally embedded little endian, and my desktop is also little endian. So yeah, just for performance reasons, I've decided to do that. But I've written it so even if you're on a big endian system, it will still serialize it correctly. It's just more expensive on a big endian system because you have to convert it to little endian. So then you can also see that test 1, and then I've got my test data, and these ones are a little less interesting because you can see these are literal translations of that. So since we know the size, we don't need to encode what the size of this is. At compile time, we just know it. So you see 1, 2, 3, 4, A, B, C, D, 1, 2, 3, 4, A, B, C, D. So everything's all well and good. We can even support U64s, which are probably a little expensive on my embedded system, but you know, it's good to have the support, because if you need it, then you need it, and hopefully your linker will be smart enough to remove it if you don't need it, and usually the Rust linker is pretty smart. Okay, so then I'm going to start getting into kind of larger compound data structures, so we can see how this actually deserializes. So I've got basic U8, or I don't know why this is U8. I guess this is just U's, basic U size, or unsigns. So I'm going to have this. So I'm going to do, so this is basic types, and I might end up categorizing these this. Let's do some structs. So test 1. That's not what I wanted. And then this is going to serialize into, and I actually did do a cargo format before I did this, and this probably was regrettable. because I don't actually want it to cargo format this. I kind of want my tests to show you what I'm thinking. So we'll do that manually. So you can see that first it serializes that first field, which is a U16, and then FE, it serializes that 8-byte, and then what do I have next? I have a 64-bit, so 1, 2, 3, 4, 1, 2, 3, 4. So you can see this is kind of the same thing that it was doing before, like BA, DC, CD, it's the same thing as this, but little endian. And then it serializes the U32. So, yep, it does that. Wonderful. So that is correct. And now I'm loop backing that, and then let's do some, which one is this? This is specifically slices. So we're actually going to take a U8, so test 1. So my input data is going to be a slice of U8. So this is if you were trying to serialize that. And the serialized version of it is actually going to look almost exactly the same. Let me, just to be nice, let's make this consistent. So I'm even going to make it, a little more aligned so you can see, whatever, close enough. So you can see that basically, wait, what are you complaining about? You're complaining that I don't have commas in my function declarations. Expected one of, because I didn't put a semicolon before this. Straight bound. Ooh, interesting. Huh. So now it's already complaining. Interesting. I think my trait bounds are doing something fancy here. So where is it? Line 63. So the len. Serialized.len. Left is 8. So serialized. Because mine actually handles fixed size arrays and slices differently, because with fixed size arrays you know the size, so there's no point in putting a size parameter in there. The problem is that I am doing this. So let me actually, what I need to do is I actually need type annotations here, and I don't know how to do this other than this, but let slice 1 is going to be specifically a reference to a U8 of a given size, which is 8 equals this. Found array of elements. Trait bound for U8. Deserialized for basic U8s is not satisfied for 4DE. I'm confused that my test below is passing and my test above is not passing. 4U8 is not satisfied, the trait for 40E. So it's saying that my U8 slice does not impl deserialize. Why wouldn't you impl deserialize? Probably my trait bounds down here are, this probably needs to be a deserialized and not a deserialized owned, which is just so frustrating. So do this. Oh, now are you happy? Oh, right. It's going to be happy because I switched to the Vec thing. Bar does not live long enough. Ugh. Found X. Come on, isn't this lifetime static? Isn't a box lifetime static? Isn't that how that works? So there's obviously something going on here. Okay, well, we'll come back to this. So let's go back to what we had before. That's gonna be not happy, but you know, let's do this because I'm on kind of a tight schedule here. To do AJM. Why aren't slices able to deserialize? Okay, so let's keep going. Byte slice, cool. So next I need to build up my input vac. So I just build a fairly large input vac. And then I need to some of the stuff that was easier in my test. Because now I need to actually state what the full thing is. So let's also make let mut output is a core, excuse me, stood vac of U8s. And I know I'm actually going to need, so output, because I know what my size is going to be, output dot push. So let's push in our OX80, OX08. Output dot push OX08. Again, this is little endian, so the way you should kind of read this is because this top bit is set, that means there's gonna be another byte, but this is the smallest byte, so we kind of start from the right. So we know the lower byte of this is gonna be 00. And then we go to this one, because it's 0, we know that this is the end of the sequence, because this top bit isn't set. So we essentially know this is 08. And OX0800 is 1024 in hex, and that's kind of how you read this length here. So you can see that we are using 2 bytes for length now, because we are storing more than 127 items, but we're not using 3 bytes yet. So we input.push, and we're gonna output.push, and there's no unwrap on this because standard vex can't have failable pushes. So then let's go ahead and test 1, and we're going to test input, and we're going to test, what do I do there for serializing it? I do output to vac input.dref. So let's do an input.dref to make sure it's explicitly a byte slice, and then output dot one type is more general than the other. Interesting. What if I just give you an input? Yeah, that's fine. Okay, because T is serialized. Although I'm not actually testing a slice here, I'm testing let let me try. Let me try this. I might be able to. I might know what I can do here. Nope. 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 This is going to be one of those things that I'm going to have to think about later. But that is not for right now. I am just cleaning up tests. And actually, I'll probably draw a line here. And if I don't get all the way through this, then that's okay. How long have I been going for? I've been going for 45 minutes or something like that. Okay. Well, let's keep pushing. This is... I think these reference ones... to do. Hey, look, my found a doc comment. Nope, you're not a doc comment. Okay, whatever. Let's come back. 126. So I'm not actually gonna delete all these tests yet, but this is gonna be problems with stirs again too, isn't it? Okay, if I run into this, then I'll probably bail on this right now because I like the idea of starting to clean this up, but it's not a hard must-have right now. What happens if I do test 1? Hello, postcard. This is gonna be the length, which is OX10. And then what we're going to do is we're going to take this, do this, and we're going to do 1, 2, 3, 4, 5. We're using some editor magic. And B characters, comma, space. I don't know where this one comes from. Oh, I know where that one comes from. I did one too many. One type is more general than the other. You're killing me. Things with reference types. Lifetimes. Okay. Let's bail on this. To do gem port dster test. Okay, yep, whatever. Good enough. I'll leave those tests in there for right now. Let's move on to some structures and stuff. When I say structures, I actually mean enums. So I have some enums. Let's do some basic enums so I can explain how this variant stuff works. So test 1 is going to take basic enum bim. And if you can tell I was hungry, my enums are bibimbap, kimchi, and cho, and I didn't get to shochu. So I didn't get all the way through of my tasty Korean foods. But I know this is going to serialize as 01 because BIM, you can see, is the variants 0, 1, and 2. So BIM is going to serialize as a 1. And my tests pass. Lovely. It's So let's keep going in the enums from bytes bim. So that was a basic enum that has no data associated with it, but let's do a data enum that does. So my data enum up here, bim, has a U64 in it rather than a U16 or an 8 or some other stuff in there. So let's test one this, and we know the variant number is going to be 1, so that's the first byte, and then the rest of it is the FFFF, 8 of them because it's a U64. Test 1, we got a bib, which is the 0th item, or the first one. Because it's a U16, it only has 2 bytes of data. And then we're going to have a BAP, which is a U8, which is going to be variant 2, and it only has 1 FF. Let's make sure those still compile. And then the test 1, the Kim of kimchi, has an actual structure inside of it. So you can kind of see that. So it's variant number 3, or the 4th item. So 0, 1, 2, 3. And then the struct that it contains is an enum struct. So it's got a U8 and a U16 in it. So we can kind of see that behavior here. So it's variant 3. The U8 comes first, and then a U3, or excuse me, U16 is there. Okay. So then what else we have? Test 1. So this is kind of like, this kind of shows you in Serday. Serday is kind of nice because it really just gives you a list of all the different kinds of ways that you can represent data. And implementing is actually pretty pleasant because it's essentially like having a big laundry list, like a big to-do list of what you need to actually implement. This parenthesis shouldn't be here, this parenthesis should be here. So they have like all these different serialization things of like whether you have a map or whether you have an own struct or a unit struct or, you know, a new type struct and stuff like that. Yeah, ooh, I'm going to take a break for lunch here in 10 minutes. So, I mean, you can see like this one is where you have like an actual name struct inside of an enum variant. This is where you have like an anonymous struct inside of an enum variant, but it still works more or less the same way, except for you don't have to give it a name. So you can see here, like they actually serialize to, I mean, this one's a U8 and a U32, so this one's going to be 2 more bytes, but it doesn't actually affect anything in the serialization format because this is a binary non-self-describing format. So because the compiler knows I have a U8 and a U16 or a U8 and a U32, it's only going to use the number of bytes that it needs. It does mean that your serialization format is not particularly flexible, and if one of the sides changes its data format, like you only recompile one and not the other after you change something, one of them is going to get it very wrong. So things like protobuf are semi-self-describing, things like JSON are totally self-describing, whereas stuff like Postcard and protobufs, or not protobufs, bin code, are totally non-self-describing, which means like you gotta get it right on both ends or otherwise it doesn't work. And that's kind of nice because it's very efficient, but at the cost of it's easy to get wrong. But for embedded systems, that's usually just how things go. You're also usually living in a more controlled environment. Or there's some tricks with Serday where you can have essentially an enum of all of your different like protocol versions, where essentially you put like one enum wrapper around the front, and that describes your protocol versions. So that's probably what I'll end up doing on my device, and then I'll just set a rule for myself is that I can only append data types to this, because that way you never have to worry about backwards compatibility. Because if you need to change a message, you never change a message, you just add a new one. So it's, foo message version 2. And that way I have to check whether the linker is smart enough to say like, oh, I only ever care about these 3 enum variants. I'm not going to include the code to deserialize all 27 enum variants. If you're in the chat and you know whether the linker is smart enough to do that, let me know. Hopefully it is. Okay, so that's that. We're going to have some tuples next. Did I label my enums as an enum section? No, I didn't. Enums. Tuples. So this might actually be problematic because I have... Let's do some basic tuples first. I'm going to go off data here. So let's have a 12U8 followed by, or let's call it OX 12U8 followed by an OX C7A5 U16, and then what is this going to be serialized? I mean, it's just the U8 first. So OX12, OXA5, OXC7. Yep, that compiles, which is lovely. We'll see if this other one works, because, test 1. But I haven't had very good luck with slicey data. Let's see. Let's just see if this compiles at first, because otherwise I'm not gonna waste time on it. Binary option ampersand cannot be applied to type. Nope, you sure aren't gonna work. Okay, let's go ahead and just copy over what I know the right answer is gonna be, and we will move on, because someday I will be more motivated to make this correct. This might be a flag to myself that I need to be careful about what I'm going to do, because I'm going to end up writing a function that's like send data over serial that's going to end up looking a lot like my test 1, but hopefully I'll be able to separate the bounds of like one's serialized and one's deserialized. So we'll see. It's going to be less generic than that one. This byte ones is gonna have... I think this is exactly the one I was trying to do before, and it was problematic. So I'm just gonna sprinkle a to-do. Really, the point of this isn't that I care about refactoring my tests so much. It's mostly that by you watching me and seeing how I explain my tests, where you can actually see what the layout is. Like, for example, here, like in this tuple, I have a 1U8, which matches there, a 10U32, which is in hex little endian, these 4 bytes, so 10,0,0,0 is a U32 storing a 10, and then you see OX06, which is our length, so 1, 2, 3, 4, 5, 6, yep, that matches out, and then our characters, our binary representations of characters there. I don't need another one of these. So why did I put another one of these? So let's go get our new type struct and a tuple struct. Let's go add that to all of our data structures up here. I don't know why these are pub. They really don't need to be pub. And then in like 5 minutes, I'm gonna go eat some lunch / very, very late lunch, more like an early dinner here. And then I'll be back. I'll be back streaming. I'll probably Yeah, you know what? I'll probably actually end the stream and I'll make a new one, so you'll have to leave and come back. But this one I'll just leave it like explaining Postcard through tests, and then the next one is going to be what I'm actually going to do is I'm going to take Postcard and that Cobb stuff that I did a while back. I'm going to shove that into the logging infrastructure of. I'm going to. Let's see. This is Structs. I'm going to shove that into the logging infrastructure for the Internet of Streams stuff, and I'm going to, instead of just sending streams, yeah, I know, grabbing lunch at 5 p.m. Berlin time. Yeah, I have weird lifetime internal clock schedule things. Don't judge me. But yeah, Jonas in the chat was just saying, grabbing lunch at 5 p.m., me IRL. Yes, very much. This is extremely me. As well. So yeah, tuples dropped again, U8 there, little endian. You can see the little endian doesn't stretch past different fields, but you know, that. And I got rid of varants. Originally I was making varants public, but I'm not. I essentially, like, they still work in my serializer and deserializer, but only as an internal implementation detail. I can't kind of like generically make them work with other serializers. Originally I was just going to export the varant usize type and impl serialize and deserialize so that other people could use them too. So like theoretically, if you had even JSON, you could have your varant in JSON, which would be pointless, but you know, still interesting. But it's just like limitations of Serde and the fact that I'm doing a weird thing. This ref struct is just going to be a nightmare. I have a feeling. Or maybe this will be the one that works. We'll see. We'll see. I'll at least do the copy and pasting for myself, so I only have to come back to this later. You know. Never know until you try. This is basically, this ref struct is also like kind of the magic of making sure that I can do zero cost deserialization. But yeah, again, this is a test and I don't care, and my test ends up needing to be way more generic than it needs to be. So I need to make that, and that, and test one, that, and steal my test vector from down here. When I say vector, I mean slice. Nope, sure isn't. I'm really upset that I can't just have an anonymous lifetime for this. Like, I really can't just... Where's my test one? Test one. I can't just like... No, because it's going to be like, no, you definitely need a lifetime there. You definitely need explicit lifetime. I don't know what's up with that. Okay, whatever. Unit type I already covered. Unit type literally doesn't serialize to anything. So don't send a bunch of packets with unit types in them, because that won't be useful. And let's go ahead and do my heapless data. Test one is gonna be give it the input, and then it's gonna be essentially the same thing as this, except for with the length shoved up front, so it gets an extra 4 up front. Yeah, I mean, you can see like writing this instead of this means writing tests is much easier. One second. being informed 5 p.m. lunch is ready. So I am almost done with the first pass on this, and while I am eating, I will think very deeply about what I have done wrong here and what I need to do to get lifetimes right. So test 1 input this right format right, because in my test I'm going to need core format right, not std format right. Core, even though they're the same things, and my test is obviously not in a no standard environment because tests don't work in no standard environments unless you're doing fancy things. Okay, cool. Well, hopefully that was a lightning and illuminating tour of how Postcard actually works. The idea is to support a bunch more data types in it, and for it to be kind of my go-to serialization format for embedded, because you can do all the fun embedded things with it. Unfortunately, things like SS Marshall said, we will not support variable length arrays, which is understandable. I understand making design limitations like that, but I need that, or I want that. So I'm going to do that anyway. So instead of like forking it, I kind of went on my own and wrote it, but you know, lovely. So this was a delightful little short stream, hopefully, that showed me writing some tests. So I guess writing tests for Postcard, or porting tests for Postcard, and not getting a chunk of them working because, you know, I need to bang my head against lifetime data for things. But, you know, what are you going to do? So thanks for watching. If you are watching live, I am going to come back in probably like an hour and do some actual Internet of Stream things, basically porting over my logging infrastructure to use Postcard, and then also COBS, and maybe if I get to it, also BBQ or bitbuffer queues. So if you're interested in that, Jonas, I'm definitely going to be lifting your idea of essentially putting a BBQ for logging in there and using that. I'm interested to see, and I'll probably go back and look at your code. I probably won't get to the BBQ stuff today because I don't need it today. But I am interested in how you end up doing that. I guess you share the resource of the high priority item. I guess that makes sense. Because what you end up having with bitbuffer queues, not for Jonas knows this, but also tell me, Jonas, if you prefer Jonas or Jonas. I have never met you in person, so I don't know. But I guess the idea is that you have a producer and a consumer, and you have a task with the consumer that is lowest priority and just eating that, and then you have the producer as a shared resource that you're passing around because it is only a single producer, single consumer. So I guess that's what you do, because writing into the producer is cheap. So you could do that even with that, but then you'll end up needing to do things like locking out other data structures. But I guess that should still be fairly reasonable. Yeah, I guess that is more reasonable than I thought. So yeah, that's a thing. So I'll probably do that. Maybe I'll get to the bitbuffer queues today. Maybe not, because really what I need working is the message passing. What's more interesting that I will be working on afterwards is that making an actual desktop client that is deserializing these messages on the other side. So even my simple logging messages kind of get deserialized and parsed out to the buffer, or for non-stringy messages, it'll print like the debug version of that message so that I can actually like see what's going on. So thank you for watching. This was a short one, but I will be back if you're watching this live in an hour. Otherwise, get ready to jump to the next video. Okay, thanks for watching.